Hello everyone, I am Toygan and I will present 3D MPRAGE SEE574 project. My outline is as follows: introduction, theory, experiment and results. In 3D MPRAGE there are three parts: magnetization preparation, rapid gradient echo and magnetization recovery. And additional trigger can be used for periodic imaging like heart and liver. In magnetization preparation part, there are different options. However, in this study, I will evaluate T1 weighted images. This T1 weighted images MPRAGE sequences is frequently used, especially in fMRI, to obtain structural images. Other options are T2 weighted chemical shift and magnetization transfer is used for magnetization preparation. In second part, rapid gradient echo is used. This part is for data acquisition. Different types of RAGE sequences exist. Some of them is the same, but different manufacturer uses such different names. For example, Flash, Grace and etc. Magnetization recovery part is used for determining the contrast for T1 images. If recovery time is long, we obtain better T1. However, imaging time will increase. When we examine magnetization preparation theoretically, firstly, assume that we have M0 initial condition. After 180 RF pulse, what we obtain is the minus of it. Then, when we wait T time, what the equation in Z direction will this? It will decay according to this equation. Then, when we use 90-degree RF pulse, the vector will fall down in XY plane and it will decay with T2 star and T1 like that. We can show these equations in this figure. Firstly, in this part, what we have is M0 in that part. Then just after this point, using this RF pulse, we will have that equation. Then we are waiting for Ti, which stands for inversion recovery time. What we the decay will be determined by this equation, and there will be another RF pulse. In this formula I wrote 90 degree. However, in our case we will not use 90 degree. Flash uses very short angle like 15 or 20 degree. In slide selection part, we can see there is a spoiler here. Because this RF pulse is not perfect, then there will be some magnetization XY plane effect. We can decrease this effect using this spoiler. In magnetization preparation, we are using rapid gradient echo, in short RAGE. RAGE is for acquisition of data. In figure, GS stands for slide selection, GP stands for phase encoding, and GR stands for readout. This part, we know that this is normal gradient echo. The thing we say it's rapid comes from the fact that we are using more than one RF pulse in one inversion time, as you see here. For example, Firstly, we use 180-degree RF pulse, then wait for immersion period. After that, normal GRE sequence is used. Then we are going another phase encoding part. Then we repeat this for all plane is covered. Then we are waiting for magnetization recovery part. Then this plane is finished. Then we are going back another plane. After all this plane covered, imaging is finished. As I said before, after all slice finished, magnetization recovery interval is waited. In this part, I will formulate all the equations. SN stands for signal intensity, and is the phase encoding steps. MI could be written like that. In this equation, M equilibrium stands for magnetization equilibrium, and written can be written like that. In that part, X is here. As we said before, this part comes from inversion recovery, and because of the fact that we are using different angles, this part comes because of the more than one RF pulse usage. There is a summation of the effects. I did an experiment with this sequence. The MR machine I used is Siemens Magneton. The parameters I used is here. What I obtained in Excel plane here. You can see some artifacts in the region of eyes because of the fact that the eyes are moving in the period of readout, because some artifacts occurs in this direction. This is the images for coronal plane and sagittal plane. Lastly, I will talk about the advantage of the MPRAGE. The most important advantage of the T1 3D MPRAGE, it introduces short imaging time compared to multi-slice 2D imaging. And another advantage of MPRAGE is that we can control T1 weighting by changing inversion time. Another advantage is that because of the fact that the sequence is periodic, it suggests that it could be used for images which is subject to periodic motion, such as liver or heart imaging. And the last advantage of this MPRAGE, we can use this sequence for additional magnetization preparation, such as spatial or chemical saturation, by changing the magnetization recovery time. My references are here, and thank you for listening to me.